Hi everyone, I'm Miranda. I'm a PhD student here at the School of Chemical Engineering. Today I'm going to introduce my project, Encapsulation Strategy for Improved Retention, Stability, and Application of Food Flavors. My supervisors are Cordelia Salamulia, Yong Wang, and Mr. Brett Baker from Baker & Co. industry. So I want you guys to think about a scenario when you cook any roast dishes, like roast beef, chicken, or vegetables. You typically usually marinate the meat, put it in the oven, set a temperature, and then you're soon surrounded by this rich aroma. But sometimes the beef or vegetable still takes a bit bland. Why is the case? That's because the flavors or spices that you use to marinate the dishes evaporated during high temperature because they consist of so many small molecule chemicals that are so sensitive to the environment. That's why your dishes will taste bland. That's why low temperature, slow cooking is always recommended for better flavor preservation. So like I said before, no matter what kinds of flavors, they all consist of small molecule chemicals. And food flavors are important contributor to any food product's satisfactions and consumers' acceptance. But now our industry is facing a lot of challenges in terms of how to deliver those flavors effectively at different stages of food processing. So the first challenge is the short shelf life. The food flavors that you bought 6 months ago may not be tasting the same today. This is because of the sensitivity to environments like heat, oxygen, and light. The next challenge is the transport difficulties. So food flavors are usually produced in liquid forms, which takes up a lot of valuable space and increase the freight cost. What's even worse is that more than half of the volume is actually no flavor. It's the solvent or carrier oil, which even lower the logistic efficiency. The third challenge is related to the scenario that I just mentioned. In large-scale food manufacturing, the instability of food flavor is even more obvious, especially during like sterilization, pan frying, or like extrusion process. So the last but not least was the poor solubility. A lot of flavors are oil-based, making them very challenging to be dissolved in water-based food products, which is basically 90% of the products. And that will create clumps and uneven taste of your food. So this is where my research comes into place, to use microencapsulation that creates a physical barrier, protect the flavor compounds. So there are lots of ways to produce microencapsulated flavors, and spray drying is one of the most industrially scalable and cost-effective methods to protect volatile or easily degradable substances, which accounts for 80 to 90% of the production techniques. Actually, I can use the laser pointer. So this is the spray dryer that I'm using for my research right now. So as you can see, the flavors carried by encapsulant, or what we usually call it is raw materials, is fed from the top of the spray drying in emulsion suspension form. And then the water content can be evaporated by the hot air blowing into the drying chamber, and the powders coming down from the chamber through the pipes and all going to a collection jar, which is not shown in this photo. And depending on the raw material properties, we can get different morphologies and distribution of the flavors in the microcapsule. And what are the benefits? So longer shelf life, because of the protection against the external environment. Raw materials also gives more controlled and sustained release and improve the solubility in various food matrices. Let's have a look at the ANZ flavor markets. So by 2033, it's expected to grow to nearly $1.1 trillion with 5.4% annual growth rate. Consumers are continuously pursuing exotic and authentic flavors, which encouraged the different brands to innovate and combine locally and internationally flavor blends together. So the market trend of encapsulated flavor shows that there's increased need of clean label and encapsulated flavors using natural ingredients. We also see increased use of encapsulated flavors in plant-based food, which is normally produced by high pressure and high temperature processes like extrusion. With the technology advance with microencapsulation, there are a lot of research about doing targeted flavor release. And we also see increased application of encapsulated flavors in bakery and confectionery products because of the heat stability that prevents undesirable chemical reaction. So to align with the challenges and the current market trend, I proposed a few research questions and responses. So the first question that I asked myself was, do all flavors behave the same? So fruit flavors will be very different from savory flavors in terms of the physical chemical properties and the food applications. So they need to be treated differently before spray drying. So to tackle this problem, I optimized the composition of flavor carrier before spray drying according to distinctive physical chemical properties of raspberry flavor. And the second stage was, how does the flavor interact with the raw materials? Understanding the interactions will allow us to more efficiently encapsulate flavors. So in this stage, we designed combined carbohydrate matrix for encapsulation of butter flavor. I'll later explain why I chose these two flavors. And we also explored the effects of molecular weights and chemical structures of raw materials on flavor retention and release. The third phase, which is still in progress, is apart from the common carbohydrate materials that we use, can we incorporate some sustainable value-added ingredients to improve the functionality? Now we are exploring incorporating soluble fibers into on top of the normal raw materials to improve the heat stability and control release. The last phase, which is very exciting and important because flavors eventually have to be consumed. So we will be investigating how encapsulation affects the multisensory properties compared to the non-encapsulated ones. So we will conduct a sensory evaluation and to assess the consumer acceptance on the butter flavor when they are added into the end product, which is mashed potatoes in this case. So today I will mainly go through the first and second stages. So for this first stage, was to optimize the flavor solvents for encapsulations of raspberry flavor. So why raspberry flavor? Current research has mostly focused on the oil-based, which is lipophilic flavors. However, a lot of fruit flavors, like raspberry flavor, they contain both hydrophilic, which is water-soluble, and also oil-soluble compounds. Why do we need solvent optimization? Combination of solvents are normally used to solubilize all volatile compounds during flavor manufacturing. Although the type of solvents have been quite understood, there's still a lack of research about the selection of those solvents specifically for spray drying and their effect on the subsequent storage stability. So here is the research method. So we dissolve the different components of the raspberry volatiles into solvent mixtures, including triacetylene, propylene glycol, PG, and ethanol. And then it was emulsified by maltodextrin and whey protein to form emulsion, which then spray dried using the pilot scale spray dryer to get powders. And then we characterize those powders based on morphology, flavor retention, and storage stability at accelerated condition as 40 degrees. So the first result was about how does a combined solvents system affect powder's property. So as we can see, the control is the flavors with only like dissolving in triacetyl only, while the other samples have multiple solvents. The loading capacity increased when we used a combined solvent systems. And another two important parameters are moisture content and water activity, which reflect how sticky the powders are and they're resistant to microorganism growth. By incorporating ethanol, we can see there's a reduction of moisture content and water activity because of ethanol's lower boiling point. And if we have a closer look at the retention of individual flavor compounds, we can see the samples, particularly the second and the fifth, have better retention on most of the flavor compounds. And the protection effects of combined solvents are even more obvious for hydrophilic flavor compounds like maltol and vanillin. So to summarize the role of each solvent, we can see the triacylane mainly provides the oil phase for the emulsion. Propylene glycol improves the retention of hydrophilic components, and ethanol improves the drying rate. So the key takeaway message here is that any flavor composition should be optimized based on their polarity, solubility, like hydrophobicity of the volatile compounds before spray drying is conducted. We also look at the storage stability at accelerated storage condition to assess how different flavor compounds are retained. So the control sample here is the unencapsulated flavor dissolved in triacetyl only, which suffered from significant degradation even just after 3 days of storage. Volatile compounds with higher volatility also are more prone to degradation as expected. Also, the humidity also play an important role to accelerate flavor release. And the combined solvent system, particularly the 7,5-TR plus 25 PG, achieved the best flavor retention overall. So when you buy any powders products, when you open the powder products and then let it sit for a while, for a few months, you probably will see the clumping and cakiness. So this is what's happening on the micro scale. So before storage, you can see the microcapsule shows nice round and near spherical shapes. After storage for 2 weeks at low humidity at 40 degrees, where you can see some black dots showing up on the surface. That means the flavor and oil migrated to the surface. When the relative humidity increased to 75%, we can see significant structural collapse and loss of morphology. So next time when you have any powders, make sure you follow the storage instruction. Okay, so let's talk about something like more tasty. So the second phase was to design a combined carbohydrate matrix for the encapsulation of butter flavor. So why butter flavor? It's because it's commonly used in a lot of savory products that require heating processing. So it gives us good initiative to assess the efficiency of the encapsulation. Although solvent was important, the raw materials, it's the one that ultimately provide a matrix that protect the flavors. However, there's still a lack of study to correlate the molecular weight and structures of carbohydrate raw materials and the flavor retention and release. So here we use OSA starch and then as the main raw materials, and then partially replace it with carbohydrates with lower molecular weight, like maltodextrin and disaccharides. So the samples here are listed based on the reduced molecular weight. So OSA starch is a very good emulsifier that can attract butter flavor via hydrophobic interactions. So our assumption was by changing the materials with different molecular weight, they can potentially fill in the gaps with the branched starch chain and achieve different packing of the matrix and potentially different powder properties. So here's the initial results in terms of how the raw material selection affects the powder properties like encapsulation efficiency and loading capacity. So we can see CMD18 and CLAC reach the highest loading capacity and encapsulation efficiency, meaning that better protection for the flavor. And another property that we assessed was how well the powders can be packed, and we quantify it by bulk density and powder cohesiveness. As the molecular weight of raw materials decreased, we see the increased bulk density and reduced cohesiveness, which means that powders can be packed easier during handling. So this is an interesting graph. It could be a bit overwhelming, but I will walk you through that. So PCA analysis was used to assess what variables affect how the flavors are released and how the release profiles is based on the chemical categories of the flavor. So on the left-hand side, we can see that 3 clusters, which means the flavor release composition can be clearly distinguished between dry powders, reconstituted emulsions, and original butter flavor in oil. This is because flavor escaped differently from a solid matrix compared to from a liquid matrix to air. Comparing these 2 graphs together, we can see that the chemical compounds that contribute to sweet and sour aromas are more dominant in dry powders. That's why some of my colleagues told me they smell yogurt in the lab. And the butter, like the buttery and creamy aroma is more dominant when they were rehydrated in water to form an emulsion. And within the dry powder cluster, we can see the molecular weight of raw materials and water activity also played a minor impact in terms of the flavor release. So the key takeaway of it is that the different notes of butter flavor, whether it's buttery or acidic or sweeter aroma, can be changed depending on the form of the butter flavor, whether it's dry or wet form. So some of the key findings, as I mentioned before, from the raspberry flavor case, we know that combined solvents improve the volatile retention and storage stability. So flavor carriers should be optimized before spray drying according to their intrinsic properties. From the butter flavor case, we know that a combination of high and low molecular weight raw materials improve encapsulation efficiency and retention of butter flavors. And from the PCA analysis, we can conclude that flavor release can be modified depending on the type of carbohydrates and also the flavor form, whether it's dry or wet form, suggesting there's a potential to achieve targeted encapsulation and with different aromas that suit the specific needs of the food products. So future research will examine how different encapsulation materials and processing conditions influence the sensory properties of spray dried powders and also their impact in the final food products, which is mashed potato. So stay tuned if you want to be my guinea pig about in the sensory evaluation. If you're interested in mashed potato or trying the butter flavors, please stay in touch. I would like to acknowledge the support from Baker & Co Ingredients and Future Food Systems CRC. Let's keep in touch, and this is my email address and my LinkedIn. Thank you.